So I'm just going to show you problem 422 in the textbook. We need to find V0. So let me just complete this problem plus minus V0. And this is over the 50 ohm resistor. This is also in ohms, this is also in ohms, this is in ohms, and this is in volts. Okay, so firstly, node voltage method is identify your nodes, right? So let's see, we've got this is a node. Let me just do it in a brighter color. Let's do it in a highlighter. This is a node. And here's another node. Let's see, here's another node. And that is it. Okay. So this question is nice because it has a supernode. So a supernode is where there is a voltage source between two nodes, okay? So I'm just going to label this. This is going to be my node. No, that's not a pen. This is my node 0, just because it's going to be my reference node. I'm going to try to do it like this. You show it your reference node. This is 0 volts. And then you have my node 1. So this is V1, and this is V2. So let's start by writing what we know. This is what we know. This is 0. Well, I'm not going to call it V0 because we have V0 over there, but this is 0. This node here is 0 volts. And we do know that the difference between these two is going to be 25 volts, right? You can see the pluses on this side that they drew. So there's going to be a voltage gain that way. Basically, I just know that V2 minus V1 minus V2 is going to equal to 25 volts. Just because if you think about it, right, V2 is going to be a smaller number than V1 because there's a voltage rise. This just means it's going to be an increase in voltage that way. So the bigger number minus the smaller number will give me this positive number. So that's just how I rationalize it when writing this condition. So let me just take these things away to make it nice and neat. So yeah, V1 minus V2 is equal to 25 volts. That's going to be our one equation because there's a supernode. Cool. So let us do our calculations then. Since there's a supernode, what we do is we kind of like combine these nodes and we treat this as one big node. So let's do it, right? Let's see what is all connected to this one big node. Let's look at our let's look at our resistors. We have we have 1, 2, 3, 4 resistors connected to this big supernode. But what I see here is I'm just going to combine these two into one resistor because, I mean, they're in series. It's going to make things simpler for me. So let me just do that real quick. Take this away. This is going to be, it's going to be 20 plus 55, which is 75. 75 ohms. So now we kind of like just have 3 resistors to deal with. Yeah, so let's start. So we're going to write our equation down, which is going to use Kirchhoff's current law. The node voltage method is based upon the Kirchhoff's current law, which means the sum of all the currents going into the node and is equal to all this current, the sum of the currents all going out of the node. So current going in minus current going out is 0, in other words. But how we apply this is saying, actually not there, because whatever is here minus whatever is here, so the 2 voltages over this resistor value. Simple as that. It's always going to be the voltage that we're dealing with minus the other one. So let's go to V1, okay? Just ignore the fact there's a V0 there. We'll get to that in a moment. We're going to solve for V1 and V2, which are over here. Okay, so let's go. Firstly, let's deal with this resistor. So it's going to be V1. Just notice I'm using V1 because even though I'm treating this giant thing like one big node, it's still connected to V1, right? So I'm just going to keep using V1 for this case because that's the node it's connected to. So V1 minus this reference node, which is 0 volts, over 50. Okay, that's the first one. We just write it a bit smaller. V1 minus 0 over 50 plus, let's go to the next one, is 150, right? So this 150 resistor is connected to that node and this node. So it's going to be the one that we're dealing with, which is V2. We're dealing with the big node up here. It's V2 minus 0, because that's the value of this reference node, over this value, which is 150. Okay, now we have one last one left. It's the 75 one, so it's connected to the V2. So it's plus V2 minus whatever is here, which is still 0, minus 0 over 75. Okay, let me just write it a bit neater down here. V1 minus 0 over 50 plus V2 minus 0 over 150 plus V2 minus 0 over 75. Okay, that is the answer to the equation, Studio C reference. Yes, so now we've dealt with all the resistors, right? But you can see there's another thing that's going on here. There is a current source attached to this node. And because we're dealing with Kirchhoff's current law, we're going to look at that as well. So we dealt with the resistors, now we look at the current source connected. So here we have a current source that is moving away from this node, the node being the V1, right? Just get this away. It's the V1. You can see it's connected to the V1. Now our convention is we're going to plus anything that goes out of the node and minus anything that goes into the node. Okay? So this, in this case, this 2 amps is going out. So we're going to plus this. Plus 2 is equal to 0. And that is the equation that we have. So let's just simplify this equation. It's going to be 0.02 V1. Let's see. So that's convenient, plus 0.02 V2 plus 2 is equal to 0. Okay, so now we have two equations because we have this one and we have this one. Okay, let me just take that V away because it's a bit confusing because, yes. So then you just solve with simultaneous equations, right? I'm just going to type it into my calculator. So let me just rewrite this how I would type in my calculator. 0.02 V1 plus 0.02 V2 is equal to minus 2. So that's our one equation. And that's the other equation, right? So you just type it into your calculator using simultaneous equations. If you don't know how to do this, you tap mode. Then you tap 5, which is equation. Okay. And we have two unknowns. So we're going to select the first option, which is a in x plus b in y is equal to c in. It basically says a constant times your first variable plus a constant times the second variable is equal to some constant, okay, which is the case in each of these equations that we did. So let me just type, so you select the first option, and then you're going to have a thing to type in the value of a, b, and c. So for this equation, so because you can type in two equations, you're going to type in that is your a value, that is your b value, and that is your c value, and do the same for this case. So let me just do that in my calculator. So I'm then going to find that my answer for V1 is equal to minus 37.5 volts. And then my value for V2 is equal to minus 62.5 volts. Okay, but that's not what they asked. What they asked is the value of V0. But the thing is, which is really nice, is V0 is the voltage over that 50 ohm resistor over here. So V0 is essentially, we're just going to use V1 and the reference node. So let's just apply logic again. You see this V0 is measured with a plus on top and the minus on the bottom. So there's going to be some voltage rise, right? So to get this V0, it's going to be, so if you want it to be the positive value of whatever it's going to be, if it were positive, it's going to be the bigger one minus the lesser one. So because it's a voltage rise, it's going to be the bigger, like in inverted commas, bigger one minus the smaller one, which is going to be V1 minus this reference one, which is 0, which conveniently is minus 37.5 minus 0, which is equal to minus 37.5 volts. And yeah, that is the correct answer. So if you want to check to find the power delivered by the 2 amp source, then because that's actually what they asked in this question, they actually said use V0 to then find the power delivered by this 2 amp source. Then it's quite simple. So let's just say this was A, and B, we want to find power for the 2 amp source. Okay, so for B, let me just use a bit lighter color here. For B, it's going to be, I think your notation is P. I just used the same color, nice. Anyway, P is equal to minus, actually we didn't even have to say the minus. Oh yes, we do. Okay, I'm putting in the minus because it is going that way. So let me just redraw this. Let's say this goes that way, right? Then it will be minus 2. It's the same of saying it's this way and just 2. It's minus 2. So the power of anything is V times I, correct? And in this case, we know V0, right? V0 is going to be exactly the same over this source because of the voltage. Well, it's not voltage divider, but things in parallel with each other have the same voltage, and this V0, which is over this resistor, is in parallel with this source. So the voltage over the source is still going to be minus 37.5, and we can see now we have a minus value there because we just did the other way around. If it were the other way around, like it was still this way with a 2, then we'd put a minus in front of this entire expression. Yeah. But in this case, I redrew it the other way just to make it easier for myself. So it's just like this. And this will give you the answer of 75 watts. And you must say delivered. You know, my signs and stuff are a bit wrong here. I have to just check the convention. I think you have to say, actually, to be honest, you must put a minus here because it is a source. So you're going to get the answer of minus 75 watts. Just going to hold on this moment. Yeah, it's going to be a negative in front of that. Sorry, I confused you a little bit with the sign conventions there, but it's going to be minus that because this is going to be the answer. Now you can just say it's going to be that power absorbed. That's right, because we're saying it's negative that power absorbed because it's actually 75 watts power delivered. Okay, so either of these are right because technically it's power delivered, right? But you can say negative 75 power absorbed. You know, it's like saying you're going backwards in reverse, you know, you're actually going forwards, but you can say it in another way by saying going backwards in reverse. It'd be wrong to say it's negative 75 power delivered. You'll get that wrong. Or it's 75 power absorbed. It's either of these. So these could be the answers. Yeah, that is it for this question.